meeting is being recorded.
A very good evening, everyone. Am I audible? Okay, so let's start on with today's session. That is comparison between linear search and binary search. For that, I will take an array of, or not even array, we will take the example of square root. Okay, so if I give you the number as 25, in the answer you need to return it as 5. If I give number as input as 36, then what should be returned as answer? Yes, everyone. It should be 6. So this is our question. Okay. Now, if I talk about, if I need to find it via linear search, what I can do, I'm just writing down the numbers here. I have written the numbers up to 25. And now, if I have to find out the square root, this means what will I do? I will go to 1. And what will I check if 1 multiplied by 1 gives me 25 or not? Correct? Square root is basically, or we can say that when 5 is multiplied by 5, it will give you 25. Yes or no? Everyone is able to follow this. So I will keep this condition if the given number multiplied by number is equal value, then you need to return true. Everyone is able to get this? Okay, great. So for the 1, we will not get our answer. Then we will move to 2. Again, for 2, it will be like 2 multiplied by 2 is equal 25, which will fail again. Then when we move to 3, it will be like 3 into 3, which is again not equals to 25. We will go to 4. Then it will be like 4 into 4. Again, it's not equals to 25. And at the end, when you will move to 5, 5 multiplied by 5 is not equals to, is equal 25. Here we will get our answer and we will exit the loop. Yes or no? This is the perfect way to find the square root. Yes or no? One by one, you are iterating until you get the number, which is actually the square root. Okay, great. So everyone, since all of those who were present in the yesterday's class, don't you feel like it is a kind of linear search? One by one, we are iterating on the elements. And as soon as we are getting the number, we are just returning true or returning false. Okay, great. You can also observe that this particular set of values are sorted because like we are iterating from 1 till 25 in a sorted manner. Yes or no? So if we are able to apply linear search, we can also apply binary search here. Yes. Okay, now we will see how we can apply binary search in this particular topic or in this particular question. So for that, I will take again 3 values. Low. Where will be your low? Can everyone tell me the value for the low?
I think 2 should be because 1 is meaningless. Every number is divisible by 1.
Okay, if I give in the question 1 only, then like I give the number as 1 and I want its square root, then what will you return for that?
In that case, I'll just put if 1 equal to is passed, then just return true.
So basically you will place a separate condition, right?
Yeah.
So why not just include it in the loop? Anyways, we know that we are going to get the correct answer, right?
Yeah.
Yeah. You can keep the condition as well. It's not a big deal. Okay. So again, I am repeating my yesterday's, like you can say the naming conventions. I said that we set our boundaries here. Okay. So your minimum boundary is lying at 1 and your maximum boundary is lying at 25. Yes or no?
Yes. Sorry.
Can your square root be like less than 1? Can it be 0 or -1 or -2? No. Can your square root exceed 25, like 26, 27, 28? Again, it's a no. So your low should be at 1 because it is the minimum possible value you can get. And your high should be at 25. Or you can say whatever value you will get as an input. Clear, everyone?
Ma'am, I have a small doubt. The
Yeah.
high should be half of the actual value, because I don't think of any number where the number would be, the square root would be more than half. Like, I don't know of
Okay.
any number. Like, for example, even if we start with 4, it
Mhm.
will always be 2 or half or less than half.
Okay. We'll come on that point. First of all, let's see it with this value and then we will analyze that point. Okay. Clear?
Oh, yeah, yeah, yeah.
Okay. So here we will find our mid value. So mid value is, you know, the formula for that is low plus high divided by 2. So your low is 1, your high is 25. So 1 plus 25 divided by 2, you will get your mid as 13. Correct? Everyone is able to follow this? Yes. Now you will check if your mid, let me write this condition. If your mid multiplied by mid is equal value. Okay. So is your 13 multiplied by 13 equal 25? No, right? So what should we do in that case? We should move on to the next condition. And our next condition will be if your mid asterisk mid, whatever value you have got here, is it greater than the value? Is 13 multiplied by 13 greater than the value? Yes. So where should we move? Should we move towards the left of 13 or should we move towards the right of 13? Guys, you know that you are getting a greater value, right? If you are getting greater value toward like on 13 itself, you will get greater values on the remaining values as well. So you should be moving on the left side. Clear? So here, what should be updated? What should be updated? High should be updated and it should be mid minus 1. That is, your high will become 12. Clear? If this would not have been the, let's see it later, but right now. Now successfully one loop continued, your high changed, and now your mid will become 13 divided by 2, that is, it will become 6. Okay, now it will check if 6 multiplied by 6 is equal value. Your value is 25. So will it be true? Is 6 into 6 equal 25? No. Again, this won't be executed. Now we will move on to next. Is mid asterisk mid is greater than the value? 6 multiplied by 6 is greater than the 25? Yes. So it will move towards left. Okay. So again, your high value will be executed, like this high value will be replaced and it will change to 5 again. Clear? Okay. And your low still remains as 1. Now, if you find the mid, you will get it as 3. 1 plus 5 divided by 2. It will give you 3. Yes or no? Again, we will check if 3 multiplied by 3 is equal value. Is it equal 25? No. Again, this won't be executed and it will check this condition. Is 3 into 3 is greater than 25? No. Again, this won't be executed. Now we will get our last condition to be executed, where your mid asterisk mid will be less than value. Is this condition true? Yes. So this will be executed. Which value should be updated? Low value should be updated and your low value will become mid plus 1, which will be 4. Clear to everyone? Is it clear? Okay. So here 5 will come as it is. When you will find your mid, you will get it as 4. Now 4 into 4 is equal 25. First condition, is it true? No. 4 into 4 is greater than 25. Is it true? No. Is the last condition true? Yes. So this will again execute and your low will become mid plus 1, that is 5. High will remain as 5 and your mid will also become 5. Clear, guys? Now when this will check that 5 into 5 is equal 25, will this be true? Yes. And hence you will get your answer, that is return true. Clear to all? Okay. So what I intend to show you all here is the time complexity thing. Since it was 25, you can see here that you only iterated for 5 times in the linear search, correct? But if it would have been the bigger value, let's suppose it would have been 169, like 169, the square root is 13. Okay, so it would have traveled 13 times, correct? Like it has to travel linearly. Everyone is able to follow this? Yes, no, yes. But in terms of binary search, when we saw, it directly jumped on to 13. First of all, the first jump was here. Yes, this was the first iteration. In first, it was like running between 1 to 25. In the second loop, it was running between 1 to 13. In the next, it was running between 1 to 6. In the next, it was running between 1 to 3. Then, sorry, yeah, 1 to 3. Then it was running between, just a minute. Yeah, can anyone help me with this? First of all, 1 to 25, then 1 to 12.
Actually, it is 1 to 12 right now.
Yeah. Thank you. And then it is 1 to 5. Then next is 4 to 5. And the very last was 5 to 5, and you got your answer. So what is happening here, even though number of iterations are same, if you see right now the linear and binary search, you all can see that for linear search also number of iterations were 5. Here also number of iterations are 5. It doesn't matter in this particular question, but if I give value, let's suppose the bigger values like 196, or you can say 10,000, in these things, the numbers actually matters, because here, if you see, it will keep on iterating up to, let's suppose, 100. But in terms of binary search, it may take few jumps and it will reach the answer. Everyone is getting this point? Yes or no?
Ma'am, in case if it's not a perfect square,
Mhm.
then it may go in infinite loop or something.
Actually, this particular question is meant for like like the numbers which are perfect square, okay? Because the question is clearly saying you have to return the square root. So the
Okay,
inputs will be given only as the perfect square. Clear?
okay, thank you.
Yeah. So basically, if in the long term you compare, right now we have not learned time complexity, but when we will learn it, binary search time complexity is it almost breaks down to log n.
Ma'am,
Yeah.
so can we see one example for where we cannot see where the number of iterations are not matching in both the cases?
Okay. Yeah, we can. You can take the example of, like, let's suppose 13. Okay. I'm not writing down the entire values right now, but you can take the example of 169. Okay. So in terms of 169, you know that in terms of linear search, 13 iterations will be done. Clear? But if I talk about binary search, I will write down the values. Here it will be 1. Here it will be 169. And the mid value will come out to be
It's 170 by 2, right?
170 by 2. That is 85.
Once again, for 169, it will be 169 times. Like supposing 169 is a prime, so we have to go for all 169 times. So
But 169 is not a prime number.
yeah, okay. So I mean the time complexity when we are taking,
Mhm.
okay, then we worst case it will go until 169. So we should, by that rule, we should consider the time complexity of 169 as 169. Like remember one time you were telling that in time complexity the number of iteration could be the worst one. Oh, so I mean, yeah, you're right, maybe. Because my assumption is that it has to be a perfect square, then only we are going to the next step.
Sorry, I was on mute. Yeah. So what I'm saying here is, let's consider that we are taking n is equals to 26. Okay. So in this particular case, if you implement linear search, what will happen ultimately? How many traversals will the number do until it reaches that, okay, the square root for 26 is not possible?
I think 25 iterations right now.
25 iterations, which will be nothing but order of n. But if you talk about here the linear search, like the binary search, so you can see when you will search for 1 to 26, then for the first iteration you will get here, I'm guessing it will be 13 only. So here you will get only 12. Then from 1 to 12, when you will check again, it will go to 1 to 5. Again, it will go to 4 to 5, and then it will go to 5 to 5. Like there will be no changes in these numbers, yes or no? At the end, what will happen? Like when here also it won't be successful when it will check for 26. What will happen? Mid asterisk mid, that is 25, will be less than the value that is 26. Okay. So which condition will be executed? Which value will be updated? Can anyone tell me which value will be updated? Low. So low will become here 6 and your high will be 5 still. So you all can see that this is a breaking condition and you will break out from the loop. So you can see that if I change the number, like a number which doesn't exist actually as a square root, then in that case, you are getting the linear search time complexity as order of n. But in this case, like in binary search, still you are getting the same complexity, that is 5 iterations. Yes, guys, are you able to follow this?
Just one small doubt. The number 6 should be 5. Why? Because high is 5, low is 5. So 5 plus 5, 10 divided by 2 is 5. So when they are equal, then it break condition happens.
No, when they are equal, the break condition doesn't happen. When low becomes greater than high, then the break happens.
Okay, then if I apply it to this scenario, like what you have written, low is 5, high is also 5, then mid would be 5. So next time when it goes, as I think that low would also be okay. I'm not clear how we come to 6.
It's simple, okay? Like your number, your value was 26, okay? And your
Yeah.
mid asterisk mid is 25.
Yeah,
So this condition will be executed.
yeah,
And if this condition is executed, you need to update your low.
yeah.
So your low previously was 5. Your mid was also 5. So 5 plus 1 becomes 6, right? Like mid plus 1, that is 5 plus 1 becomes 6.
Oh, now I'm clear. Thank you. Yeah.
Yeah. And the person who was asking for the differentiation, actually, I didn't saw your name. Yeah. So are you clear with the complexity now? Sudhir, were you asking the question?
Actually, I want to see actually, so whatever you're explaining in the first case, right, by taking 25 as the given value, right? So
Correct.
for that given value 25, right, we're able to, so we are seeing in both the cases, number of iterations is 5, right? So I want to see
Correct.
different case actually. So where can we see the number of iterations are different in both the cases? That's where we have started the discussion, but some it's,
Actually, I'm saying the same thing. Like you were asking for the differentiation, right?
yeah.
So I told the same example for you only, that consider your n equals to 26. Okay. If you take n equals to 26, then you can clearly see you are doing the number of iterations as order of n in terms
Yes,
of linear search, right?
yes, ma'am. Yes.
But if you consider the same case in terms of binary search, you can see that number of iterations are not varying that much.
Okay.
Okay. And this is the thing in case of, okay, like I was discussing this particular example. Okay. So maybe if in this case I will search, I can, for a perfect square root, I can get the number of iterations for linear as well as binary as the same. Okay.
Yes,
But let's suppose I give this number as 170. Okay. So what happened in linear case? It will traverse up to order of n again, because obviously we know that we are not going to find the square root.
yes, ma'am.
But in terms of binary, you won't like notice much significant change.
Okay.
Are you clear with this now?
Yeah,
Yeah, that is the differentiation between linear and binary. Both has their different use cases, but yeah, this was the significant difference. Clear?
clear, ma'am. Thank you.
Okay, great. So yeah, you all can see. Like right now, I am not like just telling you the time complexity for the the binary search. It is order of log n, but we are going to discuss this, that how we derive this time complexity. So you all right now need not worry about it. We are going to discuss how we derive this time complexity. Okay, but you all must have noticed that there is significant change in the time complexity between linear search and binary search. Yes. Yes, everyone clear? Okay, any questions, anyone?
Can we apply the same logic in prime number calculation? Like keep on dividing by half to see whether it is divisible or not?
Prime number calculation, but ultimately you have to like look for all the numbers if it is divisible or not. Is it like you can, like, let's suppose you have to find the prime numbers between 1 to 25, okay? And the middle number that you got is 13.
Yeah, it will not
Okay,
work.
so can you
Yeah.
just ignore the numbers between 14 to 25, saying that, okay, these are not prime? You can't do that, right?
Yeah, even 17 is a 23 is also prime. Yeah, that's true.
Correct. So you can't do that. So basically, that is not applicable there.
Yeah.
I hope you are clear. Okay, then. So let's see another question for today. Everyone is clear with binary search, right? Like how we are implementing binary search and its concept. Except the time complexity thing, I hope everyone is clear with other concepts of binary search. Yeah, I want everyone to respond to this. Okay, okay. Okay, I've got 7 yes so far, expecting 20, like at least 15 people to respond. Okay, guys, respond faster. Okay, that's great to see so many responses. Now let's see our next question. The question name is floor of an element. In this particular question, you have been given an array of n numbers, that is 3, 7, -2, 15, 8, 12, -5, 20, 10, and -30. Now, you all are very well aware of the test cases concept, right? Like in a question, if you have been given the test cases, that many scenarios, your function will execute, right? Like your program will execute. Yes. So in this question, I'm just changing that part as queries. Like there is nothing difference, but we say that these are the number of queries. And I'm giving you the numbers. Let's suppose the numbers are 18, 10, 17, -3, 25, -20, and 11. And you all need to find the floor of these elements. Now, what do I mean by, let's suppose these queries are X. So you need to find floor of X. Let's suppose 18. How many numbers are smaller than 18 in the given array? Yeah, everyone. How many numbers are smaller than? Okay, sorry, I'm not seeing the chat box.
Ma'am,
9, okay.
One second. Floor, as I understand, is like when we divide the lower limit of that.
Vishnu, I'm explaining what does I mean by floor. And then if you have any doubts, you can just unmute and ask, okay? Is it clear? See, the floor of a number basically is that if I'm talking about 18, okay, so the very next number, which is like closest to 18 and also smaller than 18, that number is known as its floor. So if I see as 3, 3 is a smaller to 18, but I cannot say that it is the closest. So we will move on to the next number, but keep this as our answer right now. Then we will move to 7. Okay. For 7, if you talk about, then 7 is also smaller and it is more closer to 18. Yes. Then this will be our answer currently. Now, if we talk about -2, -2 is smaller than 18, but can we consider this as our answer as of now? Should we change our answer? See, I'm writing this values. Answer was previously 3. Then I changed that to 7. Should I change my answer now to -2? Everyone, I am asking for all of your responses. You all are studying in this class. No.
Not right.
Yeah, not. Then we will move to 15. 15 is smaller than 18 and even more closer to 18. Yes. Yes. So we will again change our answer to 15. Now 8. 8 is smaller, but it is not as like closest to 18 as 15, right? Should we be updating our answer now with 8? No. Now talking about 12. 12 is a smaller, but should we update our answer? No. Then we'll talk about -5. It is smaller, but still we cannot update. Then 20. 20 is bigger, so it is out of the range. We need not take it. Then comes 10. 10 is a smaller, but we should not be taking it. And same goes with -30. And hence, at the end, you will get your answer as 15. Everyone is able to follow this? Yes. Now, 10. For 10, I want the answer. Everyone just quickly write down the answers in the chat box and I'll see if you are correct or not. See, if you find the number itself in the array, then that is also can be the floor, okay? So you need not find the smaller value if the number itself is found. So in case of 10, you can see 10 is present in the array. So the answer will be 10 only. Then in terms of 17, which is what is the floor? Again, it will be 15. In terms of -3, what will be the answer? Guys, you understand we are finding smaller value, okay? And -2 is bigger than -3. Okay. And the more closest value, which is smaller than -3, is -5. Okay. In terms of 25, it is 20. Good. In terms of -20, is there any value in the given array which is smaller than -20? Again, -20 is smaller than -2. There is no value in this entire array which is smaller than -20. And in this case, the answer should be integer dot minimum value. Okay. Now 11, the smaller value is 10. So I guess everyone is like clear with the concept of floor of an element. Yes. Like you're clear with the concept, like if I'm saying floor of an element you have to solve, you're clear. Value of -20. I told you now that no value from the array is possible to be assigned to -20. So we will give integer dot minimum value as the answer. It is a predefined value, okay? Yes, anyone? Any questions? No. Okay. Now, a very simple approach for this will be, I did it in front of you all. One by one, I was going to the elements and checking if like the current element is smaller than my value and it is closest to my element, I was updating my answer. Yes. Everyone is getting that. So basically I was moving linearly in this particular array. Yes. And hence it makes the time complexity for the array as order of n because we are traversing up to the end. And next is we are executing this order of n for each query. Like for one query, you are traversing order of n. For the next query also you are traversing order of n. Yes. Hence, overall time complexity becomes number of queries multiplied by n. Clear to everyone? Okay. Now, how many of you want me to write the code for this particular part? Like you can say linearly, for linearly searching the floor.
Ma'am, here I have one doubt, ma'am.
Yeah.
So in our problem, so will be given only one query or multiple queries?
You
When-
can be given multiple queries or you can be given a single query. Like what I can say here, let's suppose I give you a test case, okay? Let's suppose I gave you test case as 5. And for each test case, you will be having a query. Then the queries will follow. Then again a query. Then those number of queries will follow. So it depends on the question you have been given. Clear?
Yes, ma'am.
Okay. So as of now, we are not considering the test case part and we are only considering the queries. So how many of you want the code for this? Okay, I will quickly write the code for this in the IDE. I'm writing right now. And then we will discuss about can we implement binary search in this particular problem? Okay, one is saying no, one is saying yes. Yeah, correct. After sorting, we can.
I think actually we are not trying to find a single value, right, ma'am?
I didn't get you. Can you repeat, please?
Actually, see when you see the binary search concept, right? Actually, in the given for a given list of elements, right? We were trying to find particular values present or not, right? That's what the use case we were discussing yesterday, right?
For the
And in
linear, yeah,
for binary as well, right?
correct.
So, but in this case, right, when you are talking about floor concept, right? So we are trying to find out. We are not trying to find out single value, right? We are trying to find out multiple values, which and all less than the given query value, and which is very nearest to the given value, right?
Yeah, but at the end, your answer is just one, right? Like you are returning only one answer for a specific query.
Okay.
Correct? So considering that part, we can implement a binary search. Okay, so here I will quickly take an array.
So quickly you can say that so if the output of a list, if the output of if we are expecting a single value from a given list, we can apply binary search. We can say in that way.
But in terms of linear search, also you're returning just a single value, right? Like you're searching for a certain type of element and
No,
you're
so
just returning.
actually, this is correct, ma'am. So in both the cases, we can say the same
Correct,
statement.
correct, correct. You are searching and you're getting your values. Okay, does that answer?
Yeah.
Okay, great. So I'll just take a query array here and quickly pass the queries like the numbers. Okay, now everyone, can you help me with the code and tell me what we were doing?
So loop through the array minus query with the least difference. If there is a
First of
least
all,
difference,
yeah, go one by one. So first of all, we are looping through the array. First step. Next was,
uh,
Initialize answer.
okay, initializing my answer. I am taking right now int answer as 0. Okay, like I don't know any answers as of now. Then it's better I
so,
take it as array of 0. Yeah,
so according to me, array I compared to query I.
for the first thing also, like before iterating in the arrays, we are looking for the queries, right? So we need to iterate for the queries as well.
Yeah.
Okay.
And I will also prefer replace n by array dot length. That way it is very, very clear as an indicator that it's
Array dot length.
instead of n.
Yeah, got it. Yep, say it further.
So array, okay, so in ARI minus,
If AR of I
yeah, minus. So I could be
minus
wrong. QJ. So I'm
Q
thinking,
of J.
yeah,
Okay.
is greater than, okay, I have to assign it first into something. Okay. Is that is greater than 0? No, so it has to be
Basically,
lower than,
basically, just right now, see, whatever this difference is coming, it should be the minimum, right?
and lower and minimum. Yeah, we can't have higher.
We
So
cannot have higher. So we don't know initially what our answer should be initialized to, correct?
yeah,
So we can simply initialize to integer dot maximum value, because if we assign it with the maximum value, we know that at the end we are going to get our right result. Clear?
yes, makes sense. Yeah,
Now you have to choose between that either this value, the difference value that you have written, or
yes,
your answer is bigger.
correct.
Okay. Whatever will be bigger, oh, sorry, whatever will be the smaller, that will be your answer.
And
Clear?
yeah, perfect. Yeah.
Are you sure?
Mm, yeah.
No.
QJ minus ARI.
Whatever your answer is, you should also try subtracting your QJ with that.
Yeah.
Okay. And one more thing, you know that this difference can be negative or positive and you cannot trace it. Everyone is able to get this?
Yeah, we won't be able to trace it back.
Everyone else, are you getting this point? That this difference, you never know, is it going to be a negative value or a positive value? Yes.
Yeah.
And hence we will try ensuring that by using math.mod. What does mod do? Sorry, not mod, it's apps. Yeah, what does this function do?
So it removes negative and then
Yeah, it gives you its absolute value. Yes, anyone is having any doubts?
I have one doubt here is that if we are doing abs, then for a case where it is like if the example is 20, which is higher than that, we don't want that to be an answer.
See, I'm giving a demonstration here. Your answer value is, let's suppose, this. Okay.
Okay.
Then I am considering your Q of I value, or Q of J value right now is 18. Okay. And I am considering right now that your array value is Q of, sorry, array of I value is -5. So when you will try to find this out, array of I minus Q of J, what will you get? You will get here -23, and after doing the absolute, you will get the value for this particular value as 23.
Yes.
Sorry, I cannot write it here, but yeah, for this you will get 23. Here your answer was 10 to the power 9 minus Q of J, that is 18. You will get somewhere around 9999 something value, right?
Yeah.
So when you will find the minimum of both of them, obviously this will give you the minimum.
Yeah. -23.
That is 23, right? But should you store this 23 in your answer?
No.
Everyone else, Vishnu, you can try unmuting yourself or like muting yourself so that everyone can also respond in this particular thing. Yes, everyone else. I just did. What I did was I subtracted query value from the answer also and from the array value also. And I am finding the minimum. And I got the minimum value as 23. So should I store that 23 in the answer? If anyone else is having the doubt or the questions,
I
yeah,
think
Siddhi.
I think we cannot store, right, because the values the 23 itself is not in the given array elements, right?
Correct.
Can we?
No, our answer should be from the array elements, right? And
Yeah.
if this is giving you the minimum value, you should store in your answer -5, not 23. Because -5 is giving you the minimum answer. Getting this?
Yes.
Okay. So here, you need not apply this math.min first of all. Instead of this, you can write here, if math.absolute value of this is less than this, if this is the case, then you need to update your answer as, let me just store these two values first. I have taken these two values, absolute values. Now I will check if value 1 is less than value 2. Then in that case, your answer should be, how will you decide your answer now? We know that in case
No.
of value 1, we are subtracting our array value, right? So in this case, your answer should be array of I. And in the other case around, where it can be greater than or equals to, in that case, you can write here, answer is equals to what? Answer equals to anyone, not integer.min. Guys, if this value is smaller itself, should we even update our answer or let our answer remain as it is? Yeah, is anyone saying something? Okay, we will see in a while. That's right now not updated. And at the end, right now I will just close this, and whatever value I will get out of this for loop as the answer, I will just print it out and I will print my answer. Clear, everyone? Yeah.
No, madam, you have one doubt.
Yeah,
Um,
say.
since it is a floor, we have to only pick the lower value. So in my opinion, absolute is not required because we are not considering anything higher than the query value.
So,
So I will always take array I, which is lower than QJ. I won't go with absolute, because absolute will take into consideration value which is higher than the QJ.
obviously, you have to pick array of I, which is lower than your query of I. That is for the fact.
Yeah,
Okay, just place here one condition that if your array of I is less than or equals to your query of I, then query of J, then only you have to implement all these logic. Otherwise, you need not implement it also.
yeah, now it makes sense. Yes, I was confused with that. Thank you.
Clear?
Yeah.
Yeah. So everyone else in the class, let's just run it and see what it is giving. For the first query was 18. It is giving us the floor as 17. Is it correct? Yes. For 5, it is giving us 3. Is that correct? For 19, again, it is giving us 17. Is that correct? Now for minus 34, it should be giving us like integer dot minimum value, but it is giving us integer dot maximum value. It is wrong, right? Okay. For 0, it is giving me, sorry. For 0, it is giving me minus 5. Is that okay? Okay. And for 1, again, it is giving me minus 5. Is that okay? Now I will add one more query to this. I will like to add here, let's suppose 10. And now I will again run this. So you all can see all the queries are running perfectly except the negative one. Or give one more. I want to give here, let's suppose 25. Okay, so I have given a value bigger than the maximum value in the array. I have given a value lesser than the minimum value in the array. I have given a value which is also equal to the value in the array. All the cases are working perfectly fine except the negative value, right? Vishnu, you give any number instead of 25, you give 55 also, it will work. It will give 17 only. Okay. Yes, guys. So now, how can we handle that problem? How can we handle that problem? Or leave that aside. First of all, okay, Aman, can you unmute?
Hello.
Yeah. Did you understood this code, Aman?
Yeah, ma'am, but I am confused in line number 14.
Line number 14. This one?
Yeah, yeah. Why? What is the meaning of integer dot max value?
Okay. So, Aman, for
Yeah.
every query, okay, you need to give an answer,
Yeah.
okay, which is closest to your given query, yes or no?
Yes, sir.
Yeah. So initially, let's suppose I take this number as, instead of maximum value, I take it as 0.
Okay.
Okay. What will happen in that case?
Mm,
Let's try running it, okay? Why? To predict the answers when we can run it. Okay. So now you can see for the first query, 18, it is giving me 70. Is it correct?
yes.
Yeah. For 5, it is giving me 3. Is that correct?
Yes.
Yeah. For 19, it is giving me 17. Is that correct?
Yeah.
Yeah. But now when minus 34, okay, let's take 1 as an example. When 1 comes up here, it will first check this condition. If 1 is less than or equals to query of j, yes or no? Sorry.
Yes.
Your array value is minus 5. Wait, let me just maximize this screen and try to annotate. For the value, I am saying that your array of I value is minus 5 and your query value is, query of j value is 1. Okay. So this condition is true, yes or no?
Yes.
Minus 5 is less than 1.
Yes.
Yeah.
Yes.
Now, when you will go here, what will be the value you will get? This is minus 5 and this is minus 1, right? It's 1,
Yeah.
right?
Minus 6.
So you will get here minus 6. And if you use absolute method, you will get here 6, correct?
Yes.
Yeah. Now, talking about this, you will have answer as 0.
Hmm. Yeah.
Yeah. And your query value is 1.
1.
So it will give you minus 1.
Uh,
Yes.
yeah. Yeah. But
And
it will return.
it will return 1. Correct. Yeah. So now out of these two, which one is the smallest?
Value 2.
Value 2 is the smallest. And hence, for that case, our answer will remain as 0 because I have not written a condition for value 2 lesser than. Are you
Yes.
able to follow that?
Yeah.
So what is happening is, as you are getting these values, just a minute. You can see if you were getting the values as, let's suppose, 18 or 19. Okay, these, sorry, like basically the values which can be in the start is greater than the array value they are executing. But as soon as we are getting this one very smaller value or we are getting, just a minute. You can see in the answer that for the consecutive 3 values you are getting it as 0, 0, 0. That is for -34 you got 0, acceptable. For 0 also you got 0, acceptable. For 1 also you got it as 0. Is it acceptable?
No.
Yes. No. Why? Because for -1, if, okay, I will change one of the value in the array as 1. Okay. Now, if I execute this, what answer will I get? Can you predict it? Can you just tell me what will I get?
Will you repeat?
Yeah, what?
Will you repeat the question?
Yeah, I'm saying if I run for one query, what answer will I get? Will I get 0 or will I get 1?
1.
1. Okay. I'll just run it and I will show you. See here, I'm getting it as 1. But instead of this, if I make all the query values as minus, okay, let's suppose I make this as minus value, this also as negative value, this also as negative value. All the values I'm making in the query as negative. Okay, will I get the correct answers?
No, ma'am.
Let's suppose I am just changing the values also here. I'm changing it as -10 also. If I run this, I'm going to get all the values as 0. Okay. Except the values which are matching exactly, like -5 is matching in the query. We are getting the right answer. But instead of that, all the values we are getting it as 0. Are you able to follow this?
Yes, ma'am.
So what is happening is our program is successful for the positive values, for the positive queries, but it is unsuccessful for the negative queries, right? Yeah.
Yeah.
Everyone else in the class, are you getting this? That why I did not consider answer equals to 0? Yes. Now, if I want both the negative and the positive values to be considered, answer should be something very big, because if I take it as the smaller one, it is going to give me the wrong result, because we are looking for the floor and the minimum difference.
Yes.
Yes. Everyone else in the class, are you able to follow this statement of mine or any questions? Yeah, I'm waiting for your guys' response. Okay, I got 2 response. Yeah, Aman, do you have any questions?
Ma'am, as we have written integer dot max value, then integers belong to query set elements or array element.
I didn't get your question, Aman. Can you repeat it?
Yeah. As we have written answer equal to integer dot max value in line number 14,
Correct.
then integers belongs to array element or it will belongs to query set element.
No, it do not belong to the array element. It is just a value, a simple value. I hope that answers your question.
No, ma'am. Actually, I'm not getting max. Yeah.
Okay, let's just, if you're not getting it, I will just print that value for you. Okay, like not here. It's better. I'll just print at the start. Sys out integer dot max value. Okay, let's just save it and execute it. Okay, can you see this value here?
Yes, ma'am.
This is the value which I have assigned to your answer. And every time these comparisons, like initial value of your answer is this.
Okay.
Are you able to get this?
Yeah. Yeah.
I hope you got it, that now it is not an array
Yeah.
element.
Yeah, right. I got it.
Yeah.
Um,
Any other doubts?
yeah, ma'am. Actually, I stuck in a matrix question. Due to one question, I'm not able to solve
Okay,
the
the question
matrix.
you have posted in the group.
Yeah. Actually, I can solve that question in my local machine, but when I try to random questions on hackering, then it
Yeah,
doesn't work.
after the class, I will just look into that question and will let you know the suggestions. Okay.
Yeah, yeah,
Yeah.
yeah.
So everyone else in the class, I am done with the, yeah, one thing that we missed out here was we didn't put a condition for a number which is like extreme negative and for which the flow doesn't exist. So at the end of your for loop, when you're printing your answer, before that, you can just check if your answer is still equal integer dot max value. In that case, you need to make your answer is equals to integer dot min value, and your min value will be printed at the end. That was the only condition that you needed to include. Clear to all? Okay, that's great. So now finally I am asking once again, in this particular question in which we written the code for the linear search for the floor of an element, anyone is facing any problem so far?
Sorry, ma'am. One thing I realized that if the return value is integer dot max, then it should be the answer itself or the query itself. No,
I didn't get you.
no, I think you are right. The last condition I was doubtful, but now I'm clear
Okay,
because that any number lower than that would be minimum only. Yeah.
correct. Okay, instead of that, anyone else in the class is having any question? Can you please run the code? Yeah, sure. I will just quickly run the code. I will correct the values which I made negative in the query. Okay, and just run it. So let's just comment this out. Yeah, thank you, Bhuvnesh. So for, you can see for 18, the answer is 17, it's correct. For -5, your floor is -5, it's correct. For 19, again, it's 17. For -34, it's printing the integer dot min value. Everyone, are you able to follow this? Okay, that's great. For okay, for 0, it is printing as -5. For -1, it is printing as integer dot min value. Should it be printing integer dot min value?
It should print -5 right now.
It should print -5. Yeah. So right now I'm not just debugging it. It's all your homework, and we will see this particular part that why it is not giving us the correct answer. Okay. And the remaining you can check that it is giving the perfect answers. Okay, everyone. Yes. So I will just